For the next example, f of x equals x to the fourth minus 4x squared, we have a degree of 4, which is even, and a leading coefficient of 1, which is positive. With an even degree, meaning both arrows are pointing up or both arrows are pointing down, and a positive leading coefficient, that tells us that my arrows are both pointing up. It's going up towards infinity to the left and up towards infinity on the right. To find my zeros, I'm going to set f of x equal to 0 and solve. Looks like this can easily be factored, which all of these in this section should be. So I have x squared times x plus 2 and x minus 2, factoring in a GCF and then a difference of two squares. Because I have a degree of 4, I should have 4 zeros, including multiplicity. Looking at the first factor, x squared, if I set that equal to 0, that's giving me a 0 of 0, but there's 2 of them. And the reason there's 2 of them, or a multiplicity of 2, is because we have 2 factors of x. For the factor x plus 2, if I set that equal to 0, I'm getting a 0 of negative 2. If I set x minus 2 equal to 0, I'm getting a 0 of positive 2. So that is my zeros. I have a 0 multiplicity of 2, there's 2 there. A negative 2, which has a multiplicity of 1 and goes straight through. The last 0 is 2, multiplicity of 1. If I can get the zeros right, you should always be able to get the x-intercepts right by just placing them in ordered pairs. Negative 2, 0 and 2, 0. I can plot each one of those. And my y-intercept is going to be found by finding f of 0. And f of 0 is 0 to the fourth minus 4 times 0 squared, which is just 0. Which makes sense because 0, 0 was an x-intercept, so it must then also be the only y-intercept. My end behavior tells me that my graph is going to be going up towards infinity on both the left and the right-hand side. I know that at negative 2, my 0 has multiplicity of 1, which means I go straight through. Now at some point I have to turn around to get to my next 0. I'm not sure exactly how low this turns around. You could plug in points to find out, but I'm not requiring that of you. I'm just requiring that you get a pretty good graph here. At 0, 0, I have a 0 of multiplicity 2. Remember what multiplicity of 2 says? Multiplicity of 2 says that the graph goes right up to that 0, but then turns around or bounces. We call that tangent. And then at some point you have to turn around and cross through our last 0. Notice that negative 2 and 2 are zeros with multiplicity 1, and the graph goes just straight through them. 0 is a 0 with multiplicity 2, so at that point the graph bounces. My end behavior and my multiplicity should go hand in hand. Let's say I made a mistake. Let's say I'm going to erase this. And let's say I knew my end behavior was up and up. And let's say I forgot that this was a multiplicity and I went straight through. You would realize that at some point you can't go down forever here and get to above the x-axis. And that in this case you'd be like, why is that not working? Oh right, I forgot my multiplicity of 2. And then you could just go back and correct your mistake. Because 0 has a multiplicity of 2, you know it has to bounce or be tangent, and then the end behavior does work. So the end behavior has to match up with the multiplicity. These will go hand in hand and both be correct in order for it to work out. On this next example, f of x equals x plus 3 times x minus 1 quantity cubed times x plus 4, it is already factored. So in order to get the degree and the leading coefficient, I'm actually going to have to multiply out the first term only. I don't want to multiply all the terms out. This would take all day. I'm just going to take each of the first terms with how many copies there are and multiply out each of the first terms. This is going to get me x times x cubed times x plus a whole bunch of other stuff which I don't really care about. My leading term is going to be x to the 5th plus a whole bunch of other things. That tells me that my degree is 5, which is odd. My leading coefficient is 1, which is positive. An odd degree tells me that my arrows are going to be pointing in opposite directions. A positive leading coefficient tells me that I'm going upward, up to the right and down to the left, kind of like a positive slope, although there's lots of bounces in between here. In order to find the zeros, I'm going to set f of x equal to 0. So it has 0 equals x plus 3, x minus 1 cubed, and x plus 4. And at this point, I'm very grateful that this was already factored out for me. Because now that it's already factored out, I'm getting a 0 at negative 3. I'm getting a 0 at positive 1, but notice there's 3 copies of that. That's like saying x minus 1 times x minus 1 times x minus 1, which is going to get me 3 copies of the 0 at 1. The way we write that is 1 is a 0, multiplicity 3. And lastly, I'm getting a 0 at negative 4. I should have a total of 5 zeros. Because my degree is 5, I should have 5 total zeros. And I do. 1, 2, 3, 4, 5. So I do have 5 total zeros. So I'm going to plot the information that I know already. My x-intercept should be simple. If you've already found the zeros, my x-intercept is just the 0, negative 3, comma 0, and then the next 1, comma 0, and negative 4, comma 0. And my y-intercept is found by finding f of 0. And in this case, I'm just going to plug in 0 for every x value. Which gets me 3 times negative 1 cubed times 4, and I'm getting a result of negative 12. So which is off my graph ever so slightly. I'm just going to add 2 more lines there. And using my end behavior, I know I have to go down to the left, yet up to the right. Next, I'd like to graph using smooth curves, no jagged points, no holes, a nice continuous smooth line. At the 0, negative 4, I have a multiplicity of 1, which means I go straight through. At the 0 at negative 3, I have a multiplicity of 1, which means at some point I turn around and then go straight through. Your neighbor might have gone a little bit higher than you did, or a little bit lower. It's either way is just fine. We won't actually be able to calculate the turning around point until we get to calculus. The next point that I need to cross is the y-intercept. And so at some point I need to come all the way down here and turn around and hit the y-intercept. Some students may hit the y-intercept and turn around right there. We don't actually know in this point of our education. And then at the 0 at the point 1, I have a multiplicity of 3. And remember, multiplicity 3 says I do cross, which is going to help me get to my end behavior of up forever to the right, although I cross with a wiggle, kind of like an x cubed. So we have a nice little wiggle here. The higher the odd multiplicity, the flatter this is going to get. So x to the 5th, it would be real flat. X to the 7th, even flatter. X cubed is just a little bit flat, like the cubic function. And this is a pretty good graph. For our last example, we have y equals x cubed plus x squared minus 4x minus 4, with a degree of 3, which is odd, a leading coefficient of 1, which is positive. With an odd degree, my arrow is going to be pointing in different directions, and a positive, I'll be going down and up. To find the zeros, I'm going to set f of x equal to 0 and solve for x. In this case, it's a y, so set y equal to 0. All of the problems in this section will factor fairly nicely, so I'm going to group these. In the first group, I can factor out an x squared. In the second group, I can factor out a -4, which leaves me x squared minus 4 and x plus 1. X squared minus 4 is a difference of two squares. I know I need 3 zeros because I have a degree of 3. The 3 zeros I'm getting are +2, -2, and -1. None of these have any multiplicity greater than 1. They all have multiplicity of 1. I don't have to note any multiplicity of 1. So at 2, at -2, and at -1, each of these values are going to go straight through using my end behavior. My x-intercepts should be simple if you've got your zeros. -2, 0, 2, 0, -2, 0, and -1, 0. To find the y-intercept, I find the value at f of 0, or in this case, just set x equal to 0 and find y. So we have 0 cubed plus 0 squared minus 4 times 0 minus 4. Again, I like this part of the problem because 0 plus 0 minus 0 is still just 0. And I'm getting y equals -4. So when x is equal to 0, y is equal to -4, and I can plot that right here. I know that my end behavior is down forever to the left and up forever to the right. At the 0 at -2, I have a multiplicity of 1, it goes straight through. At the 0 at -1, I have multiplicity 1, so at some point I have to turn around to hit the next 0. I've got to hit the -4, turn around at some point so I can come back and hit the 2. It doesn't have any multiplicity, so it goes straight through. And that's a pretty good graph. It's not great, it's not perfect, but it's a pretty good graph of the polynomial function. So we have now met the goal of this section, which was to graph polynomial functions with exponents higher than or equal to 2. Remember, they make smooth graphs, no stops and no starts, no sharp points. We found the end behavior, and we found the middle of the graph, the peaks and the valleys, by finding the x-intercepts, or the zeros.